enable a one-click logging from Warpcast to our own apps. Well, we'll be using NextAuth and NextJS. You can actually literally do this in any browser, and I'll just quickly jump to some of how it's actually done, because the actual credential stuff is universal. So if you're just following the tutorial and then change it for your framework, whatever you're using, Svelte, you're potentially not even using Next.js or whatever, and you just follow through the tutorial, you'll actually be able to pick up how it works and then just implement and adjust it to your code, because basically we're building an authorized function that takes in Farcaster frame message and just logs the user in. Okay, this is what we're doing. Start right away. We need to simply start by running this in the terminal. We'll be using AuthKit, which is provided by the Farcaster team. Horse facts, thank you. And I have this little nice one-liner command, boom, and we're basically just waiting for this to finish and up. What we're doing is we're using the auth monorepo, getting the newest AuthKit and AuthKit sample, and we're going to use the literal Farcaster AuthKit sample, but we're not using the one with white, we're using the one with NextAuth, because we're Next.js and using that. So we're not also doing that clone, because first of all, we're using npm. Second of all, we're also removing the literal auth repo git. We're moving the sample out, so we only have the sample in one folder, and we're going to start a dev server. What's the advantage of it? The literal advantage is simple, that we don't have the full auth monorepo, because we simply don't need it. We just need the sample. And now we're up. We can look at this link. This is our localhost. This is our test environment. It's going to build. And this is the sample. We can now sign in. You can sign in with our Farcast. It's going to show our profile. Beautiful. Works right away. We already have success. So, what are we going to do next? We're going to just stop that server. We're not going to need it. And as you can see, we now have a Git repo. If we go git status, it's all new. So there's nothing in here. There is a git ignore, which is nice. If we go up, well, we're in home again. So we're not in the AuthKit monorepo thing. So we have a new clean repo. You can start your project right away from one command, and you already have AuthKit signed up and working. Nice. So we're going to follow through with the rest of the blog post. This blog post is at detect.vision, as is a lot of other awesome Farcaster documentation, quick start with frames, whatever. So we'll just go through. We will realize that we will need our .env environment to be set up with NextAuth, and we will need it to have an inner API key. You will need to change this localhost to whatever you're using, and you will also need to change the auth URL to your domain. So if you're, for example, deploying on Virtual, you will need to change that to your either custom domain that you're using, or just use a Virtual, or just exchange it for Virtual URL for that environment variable, or set it in the env variable to Virtual. If you're deploying in Kubernetes, you'll need to set the .env for the Docker container and the pod in your manifests. The inner API key you can get at the webpage. Also, all the stuff we're doing is in the NextAuth docs, providers, there's credentials that we're going to go through, but we're following through. Okay, what are we actually doing? This is our goal. The whole goal of what we're doing is take a Farcaster client showing our frame, and the user is going to click a button. On that button click, they're going to go to our server. Our server is going to serve them a magic link. That is why we're able to do individual one-click signups, because our user will tell us with their signed message who they are, and we can return them an authentication link. Then the user goes to our webpage and they're already signed in. Well, they're not already signed in, we just signed them in instantly, so they don't even notice. Why aren't they already signed in? Because this is all server-side. The Farcaster client is replying to our server. The user doesn't visit our frontend, so we can't set session cookies. We can't set session cookies in the user browser. That's really important. That's why we need to do it that way. And the only way, according to the Farcaster documentation, if we go to the reference frames spec, in the button actions, you'll see there's a post redirect. So the post redirect action sends an HTTP post request to the frame or button post URL, which means our server is going to get a request. And what can we do? We can receive the signature to our shit, and respond with a 302 and a location header with our URL. Yes, which means we can reply with our magic link. That is awesome. So, following the tutorial, there's some security stuff. Read through the docs. We'll get through security at the end. And we'll add a custom credentials provider. Okay, so we have that code. We can go into our little fun code editor. Yep, trust the author. Horsefacts, nice guy. Also, we want to open pages. And we want to open our API NextAuth. This is where we're going to live now. Also the .env, you simply go here, new file, .env, and you go copy that shit, paste it in, and obviously I'm not going to fill, this is 301 for me, and I'm obviously not going to fill my API key and auth secret on video. Nope, not for you. We can actually look if we're scrolling through and we're building our custom credentials provider, we can actually look at how this works. Okay, here's a schematic again. The user presses the button. This button contains user ID, timestamp. Timestamp is nice for security against replay attacks. And our server will send back a link that contains the sent message. Why? Because then this link with the sent message will be sent to our server again, and in our front end we will realize that URL parameters are there, send it to our credentials provider, check that it's actually valid, and then log the user in. So what did Horsefacts do? In the credentials provider, he is taking a message. So if we go to our sample and do sign in, this is getting a message and signing you in. We are going to do the same thing, but not with this QR code flow, just with a frame and do magic. But this is fun code to look at. If we just ignore what Horsefacts did, we can simply start off new. Come on. We can do our own credentials provider, which is nice. So, how do we do that? Back to the tutorial. We can do a credentials provider with the ID Farcaster frame. We will need that ID to tell the backend on sign-in which credentials provider we want to use. So we can simply copy that over, go to our little tutorial fun, and be ready to use it. What's that saying? Yeah, okay, we don't have all the tabs set up yet. That's okay. Then we can then since we set our name and the ID of the provider, we can add the credentials. So we can go back over again. We can add our credentials back in. Why is that important? This is important because our signed message bytes are just a string, and we need it to know what we're actually using. If we look at what Horsefacts did, the AuthKit is using a message, a signature, whatever name, and PFP as credentials. So all of those are potentially put in. It's mainly the message and signature probably. And we also have to tell it what to log in with. This is what the auth endpoint needs from our front end. If we then go and scroll a little bit down, we will see that we will need to do an authorized function. Okay, this is the fun part. Why do we need to do an authorized function? The authorized function is for our NextAuth backend to actually do authorization and then return a user object to actually log the user in. That is why we need to do that. So this is where our actual authentication happens. And what happens here? We will create, and this is where Nanar comes in, a new Nanar API client, because we're going to use Nanar to validate a message. You could do this with any hub, any other provider, Aztec, could use Pinata as well. They also have an offering. You could go directly against hubs. What we're doing is, if you look at the hub API, you can see, okay, there's APIs for all that stuff on hubs. You can see how to use it. You could literally just call any kind of hub. This could be your hub URL or the public hub, whatever. And you can also verify messages against it, which is validate message. I'm not sure if there is a validate frame message here or if it's in the gRPC API for verifications, but no, not for the message, but validates a message against the hub. You can look at that. We're just simply using Nena. Then what we're going to do is we're going to get a response from Nena. We're going to simply shorten that stuff to make it easier. And then if that message is valid, because we didn't fail here, we're going to simply return. Otherwise, if that fails and that isn't valid, we're just going to just throw an error, return null. Null means no login. A user object, and we're going to use the same user object as the sample of horse facts. If we just simply look here, ID, name, image, this is why we stole it. And we're just simply changing the Nanar API types to it. If we look at the Nanar docs, you can also see what we did. Gonna go here, simply go 200, and then you can see the response type. And you can see that our interactor is giving us the username, the PFP URL, and the FID, and this is basically what host facts it's also doing here. FID, name, PFP, right? So, going back to our little fun tutorial, we can go and we can just take our new credential provider, go to our code and input our new credentials provider. And now the types, it's actually not annoying us anymore because the types are now correct. We have also supplied an authorized function. Nice! We're good. That's basically all we need to do, right? Reset up. Yeah, we need to add Nena, which you can do by going to your code and adding the package. And then at the top of your page also importing the package. So you just simply go, copy, yay, at the top, add another dependency. Who doesn't like dependencies? And then you can wait for this to complete at the bottom. We're not going to wait for it. We don't care. We're going to run the background. We're going to read our own tutorial. Then what we'll see is that we need to add a frames endpoint to generate the authentication links. Okay, why do we need an endpoint? Well, we looked at how our post redirect works. If we go back to the top, we will see that our server needs to respond to the Farcaster client before the user comes from the frame to our web page, right? So here we need to return a link. This needs to be done by an endpoint somehow. And Farcaster frames, as we have seen in our actual specification, actually requires us to send a post redirect with a 302. 302 is really important because you will see that in NextJS, the .redirect will actually return 307 or 308. Why? Because 307 and 308 require the browser to still keep sending post requests, so 302 is fine with the browser then just using get. The frame specification says we need 302, so we actually need to manually specify that we're doing 302. But first, let's create our route that can actually handle the post request. So we're just creating a new file, create auth-link.ts, and that way in Next.js, because it's file-based, under API auth, create auth-link, we will have our post request handler. And going to our tutorial, we can copy that code over, which is the scaffolding. And now we have our handler. This handler looks at the request. If the method is not post, if it's not a post, we will just simply return with a not allowed error. And otherwise, we're going to handle the post request. And if there's an error, we're going to handle that error. Why do we want to handle that error? Imagine you're a user in a Farcaster client and you're clicking on a button. Well, because what we do is we send it off to our server and respond with a link, the Farcaster client doesn't know where to send the user if we don't return a link. So we need to always return a link. If we don't return a link, the user will not know where to go, the user will not end up on our site, and the user not ending on our site is worse than the user not being logged in. We're trying to increase conversions here, not stop conversions. So we're going to go through, and this is also obviously described here if you want to read through it. And we're simply going to handle the error first. Why? Well, we need to, as I said, just return a simple link. So we'll go over to our code, handle our error, and we will just also log the error. So now logs will see, oh, there's an error in create auth link. The error gets logged. User doesn't see it because it's our backend. All good. And this is the important part. We're not going to use res.status 302.redirect. If we were to do that and redirect to this link, then we'll have that issue that this function this little freaking function from next will return with a 307 or 308. This will take you hours to debug if you don't look at your logs and see what the response code is. Trust me, just don't do it. Write the head, set it to 302 as the status code, set the location header to your URL. We're setting that here. You could also do that manually. You could also enter detect.vision, though our webpage is likely not going to respond or be good for you. So send users there if you want Farcaster builders or documentation. And this is just simply the root URL, so they're going to get sent to the root of your webpage. If you have your app on /app, you also enter that. Do whatever you want. This is just send the users to the webpage, make sure they're at the webpage. Now we need to handle that post. Okay, so in that post, what are we doing? We're taking the frame request, which is like the frame server sending information over to us. We're going to look for any kind of input, because potentially there's an input field in our frame, and in that input field, the user is going to go, oh, here is my fun input, mama. I want this as context on the webpage. Woohoo! Oh, and we want to deliver that to our webpage. The webpage can handle it in however it wants to handle it. That's why we'll just take it from the unclusters data. What you could also do here is do a verification. You could verify that the message is actually valid. So you could, like in our authorize, you could go and hit the Nanar API with it, and in the Nanar API you could simply go to validate a frame action. In that frame action you could go and from the assigned message bytes you could then look at the action interactor, and you could pull the input from there, from the action. So action.input is available. Though we will save that one API call to Nanar, because we know that it's in the signed message. So in our actual code, we can look at the signed message, look at the response, potentially do the API calls there. Or in our case, for the little sample we're building, it doesn't really matter. We're not care about the input being correct or not. But this is one thing you need to be mindful of, security-wise. And then we're also taking the signed message and we're just going to append it so that our URL parameters now carry that information. So if our user then gets redirected to detect.vision, which is our page, and then we will have the input here as our fun little input, right? And we will also have the signed message bytes. And in the signed message bytes, this is going to be all the fun signature. And this is all we're creating. We're doing nothing. No validation, no nothing. We're just taking what the user did in that, returning that link, because if the user now clicks that link, our side is going to get that information. If we just link it out like this, then we have no information. There's no information being transferred, so we can't log in the user because they didn't provide us a guarantee that they're actually the user, right? So if we just take that fun little logic, turn it over, then we're good. If you want the types, because we're obviously using TypeScript and we want types, the types are from Coinbase's on-chain kit. They're on GitHub. You can simply go here. It's frame request and frame data. So we will just be happy that the types are coming from them. We don't have to write our own types. You could technically also add Coinbase on-chain kit as a dependency, especially if you have a larger code base. This actually makes sense because on-chain kit is the frames tool best built to just be plugged right into any TypeScript database and be used to validate frames or actually build frames. The others like Frog and frames are more built to frames to be JSX and Frog to just quick start you. While for larger code bases and integration, I prefer on-chain kit. But we have that data. Obviously, we're coding nice, so we will say types from actual on-chain kit. And this is important because any other dev knows that these types are from here. So if they're wondering where they're actually coming from, what's the definition, or potentially if they're outdated, they can go to that link now and check. So now we have actually created our auth link. So what we just did, if we look at our little sample graphic that we have up here, is we have now created that magic auth link in the middle. So where we are right now is we have now handled the user clicking a link to our server, sent back an auth link. And this is actually just the create auth link. What we did before with the credentials provider has nothing to do with it. This is actually later. We also need to build a frame. Yeah. And we're going to do that right now because right now there's no frame. So if we simply build our frame, we will see that in our index, frames are just head parameters. So we can simply adjust our home function and take the frame here. That frame actually uses our process NextAuth URL to show a frame.jpg. You can make that whatever image you want. So if we go into our index, you will see, oh, there's like the home page, and this home page renders content. Content is a function down here in that sample. So we just want to adjust our home page. And in our head, we want to add, we just want to add our meta tags. Now our meta tags are in, our redirect URL. So the actual post URL is going to be our API route. So in our case, that redirect URL is going to be this API auth create auth link, also dependent on our auth URL. So we're going to just set this as a global thing, and it's going to be our redirect URL is going to be this API auth create auth link. And the fun about this is you can actually see this here. So it's API auth create auth link. This is why the link has to look like this. And then now this redirect URL is used as a post. And because we already talked about it before, the post URL is where the frames client, the Farcaster client, Warpcast, Supercast, whatever, is sending our requests. We know that we can handle it. We'll get it here. We will just do this new link, send it back. And then in our frame, this actual button action, the redirect, it's like we could name this go to our web page and be logged in. Yeah, this could be our button name, or it just could simply be login, or it could be settings. And if it's settings, you may want to create the link here to actually go to your settings page, right? And you could create multiple links. It could be context dependent. You could do, okay, if our actual, like the frame request dot, like in our frame data, the button index is 2. So if the second button is pressed, then we want to send him to the settings page because we know in our frame that here we define a second button and call that settings, whatever. Right? We're not going to do that. And if you do that, you actually want to verify their signature because then it's actually important where they go. Here we just want to log user in. It's a simple sample, right? If you want to work more with Farcaster frames and all that, I highly recommend you to go to detect.vision, go to the quick start Farcaster frames, and as easy as that tutorial, you can just read through and learn how to actually build frames. So now that we have built a frame and our fun little frame here can actually do all that process, it will send the user back and we will need to handle the login, right? This is the fun part. So if we go Warpcast, there should be some developer frames in that endpoint. You will be able to test your frame if you deployed it live. Otherwise, you can test it locally. How to test it locally? Simply set up your debugger, quick start Farcaster frames. Okay, we're just focused on making the logic work here. Then we need to actually handle the login on our web page. So we know that the user gets this auth link, goes to our web page, and now we need to handle the login. And the login we also know is coming from our input and signed message bytes. What do? Well, back to our index where we actually do the code, we will see that in our little app, we're doing some login, blah, 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 and in our profile, we're already handling stashing. So I'll just go into the profile. You could just do whatever you want in your code, And in our little fun profile, we're going to tell it to use the router. And then we will likely also need to add it. So we add the dependency. And from that little router, we will be able to now get the query parameters. So we're going to use an effect so that it doesn't bug us, and we're actually good because we're in React. We'll simply go update our imports, and we will see if there is signed messages. So if we get an auth link, an actual auth link, and didn't have an error, and we actually have our signed message bytes, the user goes here, we will check for it. So this is where we check for it, and now we're just simply logging. Oh yeah, it exists, it's fun. But what we want to actually do is we want to actually go and check if the signed message bytes sign in. Well, okay, there actually is a sign in hook that we can use, and this is the sign in hook in NextAuth. So if we Google it, we will go and find it, and there we have a sign in hook, and that sign in hook is described on the NextAuth JS webpage, and feel free to read up on stuff there. We're simply using it here. We're going to use the signed message bytes, and we're doing no redirect. We simply just want the user to stay on the page, do the backend, and then our session here is going to update, and we're logged in. We don't need redirects. So then, well, we also want to reset the URL parameters. So if the user were now to click here and we just log them in, they would still have this like really long link with all our like signed message at the top. So we don't want that. So what we can simply do is we can just easily tell the router, because we're using the router now, to replace our router with nothing. And because we're doing that, now all our signed messages are gone. So if you want to handle input here, you could then also go, okay, if router.query.input is not, is basically defined, right? And then you could go and console.log your input, whatever, right? Or handle it, or do whatever kind of fun shenanigans. But this is how you log in a user. And now, because you're getting that sign-in back, you're actually calling your backend. This is actually calling the credentials provider with Farcaster frame ID, because we set it to call our Farcaster frame provider in the sign-in. If we look at the type, we will literally see this is the provider. Provider. Credentials provider, Farcaster frame provider. Authorize function, this is doing our authorization, returning a user object, and this user object we can see will be our little fun session here. Right, this will be part of our session. And this is also used, you can see session user, this is the user object we get back, and this is why we're returning name and whatever. So, checking a little bit, this is also now handling the input, and we're creating like a set input in the state. We may not even care about that. And then for security reasons, what you may want to do is adjust your authorize function. In your authorize function, we're not checking for timestamps. So what can happen is that because we have it all in the link, one can simply just copy the link and paste it again, and we will log them in. We don't want this to happen. What we can do is we can go to our authorize function and check that the action timestamp. So from the action of our signed message that Nanar has validated for us so nicely against the Farcaster hub, the actual signature is not older than, in this example, 5 minutes, 5 times 60. But what you want to do is you want to potentially make that a minute or whatever. Just simply use the code that is here. Also, there's a small little mistake that I will need to correct. So this will actually need, if you want to do that, This will actually also need to be multiplied by 1,000. As you can see, we're multiplying by 1,000 here because date now is milliseconds, and this is seconds. So you need to do validation here as well. Then in your if statement, if that is not the case, if it's too old, you can return null. And we'll also need the action timestamp. And the action timestamp actually is a string. So we will need to create a new date from it, get the time, and that time is always in UTC, luckily. So we don't need to do time zone conversion. But here in our date now, this is going to be the local time of your server, so we're going to have to get the value of, and this is actually, and then we're good. And then this comparison works, and we can return null. Now we have actually fully implemented it, and we're done. We're also checking that it's not older than 5 minutes. And you need to know, this 5 minutes is only from our user clicking basically a frame, right? Getting that response back and then signing in. So this is actually like 5 minutes, actually really long. It's actually lenient. If the user takes a while, takes a piss, looks at his phone and then logs in, you'll still be fine. A minute is likely also good to potentially also. Depends on the security of your application. So how does this actually look in practice? If we are simply going to our little friend Webcast, you can see that if we go to our frame validator, we can call proxystudio.detect.vision, which has this little sign-in already implemented. You also need to specify the protocol for it, and then you're going to be able to be signed in. And here we can do an input. We can simply go and query the dev channel. We can get the link, and this is why it takes a while, right? Here at the bottom, this is sending the post request. So this is all we talked about. This is sending a post request to create auth link to our API, and this is getting the actual link back. And you can see, oh, this is our input, it's dev, it's what we entered here, and this is our long signed message. I understand that I want to leave. This will reset the long link. Wait a bit, and then we actually signed in, right? Welcome, Samuel L. Huber. This is me, and our input is already also in our input field, because what we did is in our index, like it is in the blog post, we're actually using the input set input, and this input we can use in a field. So for example, here we could now go and make this the input, and by doing it, this would be our input, and then we would need to define input and whatever. You can look at that in the actual tutorial code. And you can see it worked. Now, if I wanted to query that, this is a Farcaster channel data exporter. You can look at it. It's a fun little tool. If you have a channel, you want to get the data of all the people following the channel, the username, FID, connected wallets, and their bio. Feel free to use it. Otherwise, check out the general webpage on detect.vision. You can learn more about Farcaster. You can also check how it all works in the architecture diagram, or you could also hire us to build your Farcaster apps. Feel free to share this video. I hope this helps. Leave any questions down below in the comments. Thank you.